Arithmetic sequences follow an adding pattern. Geometric follow a multiplicative pattern. So in this first one, it looks like we're multiplying by -2. -2 times -2 is 4. So this is geometric in nature. The next one looks like I'm subtracting 14, minus 14, arithmetic. Next, let's see, we're adding or subtracting 10. Subtracting 10 each time. And the next one looks like we're dividing by 2. Half of 150 is 75, half of 75 is so geometric in nature. So multiplication is a geometric relationship, and adding or subtracting is an arithmetic. Okay. So first of all, this is an arithmetic sequence because we're going up by 3s. The very first term is a 17. That's pretty easy. Whoa, how do we find out that term? Now, the key is this formula right here for arithmetic. You start with the very first term, and then you start adding the differences, n minus 1. You take one less step to get there because you're in the first position. So if I'm doing the position of 154, that would be a 17. And we're going up by 3s. And 154 minus 1 is 153. And we would calculate that value. Comes out to 476, I believe. Same thing, if we wanted to know what's in the 26th spot, we would do the first term, the common difference, and then 26 minus 26 minus 1 is 25, so 75, 85, 92, I believe is our answer there. So the key to this, of course, is this formula, which will be provided on the quiz. Alright, first you got to figure out if it's geometric or arithmetic. This is geometric because we're multiplying by 3. This one is arithmetic because we are subtracting 12 each time. So the way it works is the formula is the first term 8, the common difference 3 to the n minus 1 would be the explicit formula here. This is your common multiplier, this is your first term. Very similar formula over here. First term is 72, common difference, and n minus 1. These are the two formulas, and all I'm doing is putting them into the two basic formulas, which look like this. That's the geometric one, and this is the arithmetic one. This is requesting the first term in the sequence. So the idea is you're sitting out here at A35, and your number is 156. Now it's an arithmetic, and it's been adding 7, so we've been adding 7 a whole bunch of times to get here. So if we want to go back to the first term, basically we take what we're at, and we're going to back up. And we're going to back up 34 steps, and every time we back up, we're going to back up 34 times. Because the idea is that if we're at 35, we're going to back up 34 spaces to land at the very first one. So if we take 156 and we subtract 34 times 7, we get an answer of -82. The very first term in this sequence was -82. So we have 4, and then it looks like we added this one, and this one, so we're at 7. Then we added this one, and this one, so we're at 10, and then we added these ones, so we're at 13, and we see there's a common difference of 3 each time. So our formula is the first term, dn minus 1, and so our formula would be 4, the thing we start with, adding 3, n minus 1. That's our formula, the explicit formula. And then what we're going to do is put in a 32 here. And so we get 4 plus 3 times 31. So that's 93, and 4 more is 97 would be our answer. Similar problem. First term's got 1, the next one's got 5. And what happened there is it added 4, and then it looks like it added 4 more, so it'll be 9. And then another 4, so 13. So our difference again is a 4. And the way it works is our first term is a 1. Our common difference is a 4 and minus 1. We are going to, so there's our formula. And then we're going to plug in 32 there. So then it would just be 1 plus 4 times 31, 124, so add 1 is 125. Alright, this is a sum this time of a series, and we learned from Carl Gauss that you take the first term and the last term, add them together, and that will pair up n divided by 2 times. So there are 16 terms in the sequence. 121 is the first term, 361 is the last term. So that becomes 8 times 482. And it comes out to 3,856. First term, last term, n divided by 2.